Alright guys, welcome to our review test study guide here. I've provided you guys with a little handout called How to Graph for the various types of functions. Now, this is a different kind of review than what we're used to. This is a review where we're going to review how to graph a variety of different types of functions. And I've given you a list here of all the different kinds and how to do it. So let's go ahead and get started here. Once again, you have to do the evens, but odds are provided in case you want a little extra practice with their answers. The last page. So number 2, we want to graph this, and this is a linear function, and it's of the form ax plus by equals c. The first thing we want to do is change it into y equals mx plus b form by getting the y by itself. So the first thing I'm going to do is I'm going to subtract the x on both sides. And then I'm going to divide both sides by -2. This here is going to become positive because you're dividing a negative by a negative. Also, you could think of there as being a 1 in the front, and I think it's a little bit more helpful to write it like this rather than x over 2, although those are the same thing. The next one becomes positive 4. So after you do that, you're going to use the steps for graphing y equals mx plus b to solve the rest of it. The first thing you're going to do is plot the b on the y-axis. The b is the number all by itself without an x, so in this case that would be 4. So I'm going to plot that number on the y-axis. And then I'm going to use my slope after that to find the next point. So I'm going to rise 1 and run 2. So rise 1 and run 2 from there would put me there. Up 1 over 2. And go ahead and connect your dots, and at that point you've got your graph. Okay? Some things to keep in mind is that if you ever have a negative slope, you would go down 1 and over 2. All right? Let's go ahead and move on to our next question here, number 4, which is also going to be a linear function. But this is one of the ones that look like this, where you have just x equals a number or y equals a number. So we're not going to use this information, but we will be using this one. When you have y equals a number, that's simply a horizontal line. So to graph y equals 4, basically I'm just going to go up 4 on the y-axis, and then I'm going to draw a horizontal line, and I'm done. That's the graph of y equals 4. All right, let's go ahead and move on to our next set. This one is going to be like this situation here. And so for that one, we're going to draw a vertical line. So we go over 1 on the x-axis and draw a vertical line. And that's it for that one. Let's move on to our next one. Number 8 is an absolute value function. You can tell because there's absolute value bars on it. The first thing we're going to do is you're going to factor out the b, take the absolute value of it, and multiply it by a. So I'll show you that step in a minute, but in this expression here, whatever number's with the x, that's my b value, and I want to factor that out, take the absolute value of it, and multiply it by a. So I'll demonstrate that for you. What I want to do is I want to divide a 2 out of this expression here. So if I divide 2 out of 2x minus 4, I would be left with x minus 2. Okay, so what I've done is I've taken this number in the front and I've divided it out. The next thing we're going to do is we're going to take the absolute value of that number. So what's the absolute value of 2? In other words, we're going to separate this number from the rest of the absolute value. Well, the absolute value of 2 is 2, and 2 times 3 is 6. So that's the first thing that we're going to do. After you do that, your vertex will be whatever number is being subtracted from the x and the number that's being added to the absolute value expression there, put together. But we have to remember this number will always be the opposite of whatever it appears to be in the equation. So for instance, here this is a negative h, but here I write a positive h, and vice versa. So in this case, that's step A. Step B, my vertex is going to be the opposite of this number, which is 2, followed by this number. Now we don't do the opposite of the k, we only do that for the h. All right, step C, we're ready to graph it. The slope is the a value. That's the number in front. So for me, that will now be a 6. And I'll show you how to do slope on an absolute value function. We start by plotting the vertex. We're going to go over 2 and up 4. And then I'm going to use my slope. This is like 6 over 1. So I'm going to rise 6 and run 1. But when I run 1, I'm going to go to the right and the left. And as a result, that's going to give me a V shape. So I'm going to rise 6. And then I'm going to run 1. So up 6, over 1 and put a dot. Rise 6 and run the other way and put a dot. And then you've got your V shape. And that's how you graph an absolute value function. All right. Let's go ahead and move along to number 10. Now we're moving into the world of quadratics. So first of all, how do I know that this is a quadratic? Well, pretty much anytime you've got a square on your x value, that's going to make a quadratic. Now, quadratics can come in two forms. They can come in standard form or vertex form. And in this case, as you guys can see, comparing this equation here with the options on the right side, you can see that we're dealing with a vertex form. So when you're trying to graph a quadratic in vertex form, the first thing you're going to do is you're going to identify your vertex. Your vertex will be like we did with the absolute value function. It's just going to be the h and the k, the number you're subtracting from x and the number you're adding to the squared function. So in this case, I guess we'll call it I instead. We'll call the vertex -4 and -2. Remember, we take the opposite of that number, and in this number we leave it as it is. So my vertex is -4 and -2. The next thing we're going to do is we're going to look at the a value. If your a value is positive, then you have a happy face parabola, and if it's negative, you got a sad face parabola. So as you guys can see, my a value is positive, so I'm going to have a happy face parabola. So therefore, now I'm ready to graph this. So let's do it. I'm going to plot my vertex. I'm going to go left 4 and down 2. And then we're going to draw a happy face parabola. And that's it. That's how we graph a quadratic when it's in vertex form. Let's go ahead and move on to number 12. This is also a quadratic because once again we've got an x being squared, but this time it's a quadratic in standard form. Okay? So when you want to graph a quadratic in standard form, the first thing you're going to do is you're going to find your vertex. And you do that by this little formula here. Your vertex consists of an h and a k. So to find the h, we're going to use the formula -b over 2a. So what the heck is a and b? Well, those are the numbers up here. The number in front of the x squared is the a. The number in front of the x is the b. The number without an x is the c. So if I'm doing -b over 2a, my a is -2 and my b is -16. Let's go ahead and plug those in. b is -16. A is -2. That gives me 16 over -4, which is -4. So there's my h value. That's the first part of my vertex. All right, now we want to find our k value. And to find your k value, you're going to take that answer that we just got, and you're going to plug that in to find k. So I'm going to take my formula y equals -2 parentheses x squared minus 16x minus 28, and we're going to be plugging the 4 in to these spots here. Got to remember your order of operations when you're doing these. Exponents are first, not multiplication. After exponents, then you do multiplication. And then you're going to combine all your like terms together. So we end up with, I believe, 4. All right? And that's my k value. Okay? So we have accomplished step 1, which is to find the vertex. The x value was -4. The k value was +4. Step 2 is a lot like step 2 when you're doing vertex form. You have to decide, is it a happy face parabola or a sad face parabola? And once again, you're going to look at the A. In this case, my A is negative, so I have a sad face parabola. And therefore, we're ready to graph this. I'm going to plot my vertex. I'm going to go left 4, up 4. And we're going to make a sad face parabola. And that's it. Final answer there. All right, guys, let's go ahead and do number 14, which is graphing square root functions. If there is a b, go ahead and factor it out. And the b is the number in front of the x there, so we don't like having that there. So we're going to go ahead and factor that out to begin with. Okay. The starting point is the h and k, so that's this number and this number. Once again, h is opposite like it has been on every other problem. Now, for me, the k, they put it here after the square root, but on this problem, the k is over here, and they can put it either on either side. It doesn't really matter. So for this is step A. For step B, then, to identify our starting point, the h is -1, and the k is -1. Okay? All right, after that, we're going to use the chart to go ahead and get our graph. So let's plot our point. -1, -1 would be right there. Now, how do you do this? Well, you're going to look at two numbers. You're going to look at the b and you're going to look at the a. And based on their signs, your graph will go in one of 4 different directions and shapes. So in this case, the a value isn't present, but it would be a 1. And the b value is a 4. They're both positive. So when both a and b are positive, then my graph will look like that, where this is my starting point. So for me, my graph will look something to the effect of that. Okay? And that's how we graph square root functions. Go ahead and move on to number 16. We talk about cube root functions now. So cube root functions are a lot like square root functions. We're going to start by factoring out the b. Now in this case, my b is a 1, and when that's the case, you really don't need to factor out the b, but we could rewrite this a little bit so we could see all the pieces. There's no a, so that means it's 1. The b is 1. My h is -5, and my k is also -5. So my starting point then is the next step. And once again, that's the h and the k, where you do the opposite sign of the h. So my h is -5, my k is -5, and then we're ready to go ahead and graph. So we're going to use the chart after that. Now the starting point for these types of functions is always the dot in the center of the shape there. So let's plot our starting point first. It's going to be left 5, down 5. There's my starting point. And once again, we're going to look at our A and our B. So here's my A, here's my B. They're both positives. And therefore, I'll be using this shape to sketch the cube function. So it'll go that way on this side and that way on the other side. And that's it. All right, the next three problems are what we call general rational functions. They require a lot of steps. So these ones are the kind of the ones that are the least pleasant to work with, but we'll muscle through it. I'm actually going to do 3 examples because there are 3 situations that are slightly different to be aware of as we're doing these. So let's go ahead and begin. So the first thing you want to do with a general rational function is you want to determine the end behavior. Now to do that, you're going to compare the n and the m, and you're going to ask yourself, is n less than m, equal to m, or greater than m? Okay. Now in this case, I don't even have an n. There isn't one. So that means it equals 0. On this one, my m equals 2. So as you guys can see, for part A, n is less than m because 0 is less than 2. All right? So that means we're going to be going with option I here. And whenever you have option I, we have a horizontal asymptote at y equals 0. Okay, so that's that. Let's go ahead and move on to the next one. Part B, we want to find our y-intercept by plugging in 0 for x. And these basically just go away, and I'm left with 1 over 6. So that's my y-intercept. Step C, we want to factor our numerator and our denominator. Okay, so let's factor this really quick. We have negative x squared minus x plus 6. Now I don't personally prefer to have a negative in the front, so I usually like to start by taking that out, by dividing it out. And then from there we go ahead and we do our box method to factor this thing. Now, maybe you need to do the box method, maybe you don't. It's entirely up to you on how you factor, but the way we learned it was you put the first term here, you put the last term here, and we're looking for 2 numbers that multiply together to make x squared. Well, that would be x and x. Then we're looking for 2 numbers that multiply together to make negative 6. And that would be 2 and 3, and we have to make one of them a negative, so we'll make the 2 a negative. And at this point you want to check to make sure if it actually works, and here's how you do it. By completing your box. X times negative 2 is negative 2x, 3 times x is 3x. These should combine together to make your middle number. So does 3x minus 2x make 1x? Yes, it does. And therefore this goes here, and this goes here. Okay, so that's the factoring step. Now I'm going to erase that just to save myself some space. So I have 1 over negative 1 x plus 3 times x minus 2. All right, part D. Factors that cancel give wholes. That does not apply on this problem because in order to cancel something out, there has to be a factor on the top that cancels with a factor on the bottom, and there isn't one. So we can skip that step. But let's go on to step E. Factors left over on the bottom give vertical asymptotes. So this one and this one. I'm going to set both of those equal to 0 and solve, and those are going to give me my vertical asymptotes. So those are my vertical asymptotes. Factors left over on the top give roots, but there's no factors on the top, so therefore that does not apply. And now we're ready to graph, and we're going to use the information that we have. And so we have some useful information to create a graph. I know there's a horizontal asymptote at y equals 0. I know it touches the y-axis at 1 over 6. I know that there's vertical asymptotes here. And that's all that I know right now. And so let's go ahead and plot all that information. All right, so we're ready to graph. Here we go. Let's go ahead and begin by graphing the horizontal asymptote. It's at y equals 0. So I know that my graph has to get flat at 0 on the left and right sides there. Next, let's go ahead and graph our y-intercept, 1/6. So if this is 1, then 1/6 would probably be like right about here. That's my y-intercept. And then next we'll go ahead and graph our vertical asymptote, so at -3 and +2. All right, and now we're going to try to connect these dots, okay? Try to create a picture out of this. Now, sometimes you have enough information just to create a picture right away, and sometimes you have to dig a little bit more. This one's going to require us to dig a little bit more. Here's why. I don't know whether this graph is going flat here and going up like that, or if it's starting flat here and then going down. I don't know. So which is it? Okay, well, when you're not sure, you have to pick a point to see. So what I'm going to do is I'm going to pick a point somewhere over here. That would be like maybe -4. So I'm going to plug -4 in up here. And we'll see what I get as a result. I end up getting -1 over 6 if I do that. So what did I do? I plugged in -4 and I got -1/6. And so that point would probably be like right about here. It's going to be below the x-axis because my y value is negative. And therefore, I know now which one it must be. Remember, I drew two lines. I drew a red one on top and a purple one on the bottom. Well, it must be the one that is coming down like that because it has to go to that point that I just found. So sometimes if you're not sure, you have to plot some points. Okay? Now, the middle piece I can actually figure out. Okay? I know it has to touch this dot. I also know that it has to go flat against these asymptotes here. Now, this one's a little bit tricky, but here's what I know. I know it has to go like flat here, hit here, and then flat there. Now, some of you guys might be wondering, but Mr. Bailey, how do you know it's not going like this? And my answer is because if we did that, I would be touching the x-axis, and that's a root. And when we found roots, we found there weren't any. So it can't touch the x-axis. So the only way it could get flat against both asymptotes and hit that point is if it's kind of like a parabola-ish shape. So sometimes you can just reason your way to the answer. But if that's hard for you, once again, you could just pick some points and plug in to get a few more points. Let's do the last side over here. Once again, I really don't know. Is it going like this, or is it going like this? I don't really know. So for that, we have to pick a point and plug it in. So I'm going to go ahead and pick 3 and plug it in. If I simplify that, I get -9, -12 plus 6. That's also -1 over 6. So when I plug in 3, I get -1/6, which means that at 3 we're below the x-axis, which means that we're going for this kind of a shape again. And so here's your final answer. So yes, these ones do require a lot of time and a lot of work. They're not so simple to graph, but there it is. All right, let's go ahead and take a look at two more of these, because we just did the situation where n is less than m and you get a horizontal asymptote at 0, but we're going to look at these other two with the next two problems that are coming up. So let's see how those ones play out. All right, so step 1. Determine the end behavior by looking at n and m. So in this case, my n is 2, and my m is 2. And therefore, n and m are the same. They're equal to each other. And that means we are in this situation right here, which means I have a horizontal asymptote at y equals a over b. Now, what is a and b? A and b are the very first numbers coefficients. So that would be 1 and 4. So I have a horizontal asymptote at y equals 1/4. All right. Moving on to part B. Find the y-intercept by plugging in 0 for x. So if I plug in 0, this goes away, and I'm left with 0 on the top. This goes away, and this goes away, and I'm left with 12 on the bottom, and therefore I just have 0. So my y-intercept is 0. So far we got two useful pieces of information to help us get a graph. I know where my horizontal asymptote is, and I know what my y-intercept is. Let's go ahead and take a look at part C. Factor the numerator and denominator. So for this top one here, there's just a GCF that I need to take out. They both have an x in common, and so that would be x times x plus 3. For the bottom one, you're going to have to do the box method. Now I'm going to go ahead and skip the work for that because I've already shown how to do the box method on the last problem, and that's an old question which hopefully you guys are already pretty decent at. Step D, the factors that cancel give wholes. So those cancel, and therefore x plus 3 equals 0. We will solve that. And we have a whole at x equals 3. E. Factors that are left over on the bottom give vertical asymptotes. So I will use this one. We're not going to use the 4 because there's no x on it. So we only use the one that's left over in the bottom that has an x in it. And that's my vertical asymptote. And finally we got F. Factors that are left over on the top give roots. I only have one factor on the top that's left over, and that's the x. And so we have x equals 0, and there's nothing to solve for this one, so that's the answer, and that's my root. In other words, that's where it touches the x-axis. Okay, so at this point, we're ready to go ahead and graph. Here we go. Didn't want to make it that big. So let's begin with our very first piece of information that we found. Got a horizontal asymptote at 1/4. So if I were to say that this is 1, 1/4 would be like right about here-ish. And so I'm going to draw a horizontal asymptote here and here. at 1/4. Horizontal asymptote means your graph gets flat at that value of y on the far left and the far right end of your graph. Okay. Next, we have our y-intercept is 0, so it touches the x-axis at 0. Next, we have a hole, but we're going to do this thing last. We'll come back to that. So let's move on to our vertical asymptote. I have a vertical asymptote at -1. Now we're ready to go ahead and start. We've done everything we can. We have this one also, x equals 0 is a root, where it touches the x-axis, but we already have that. So we've pretty much done all we can. Now, I know the right side. The right side has to start here, and then it's got to come down and hit that root right there, and then it's going to get flat. So it's got to look something like that. That one has to do that. The right side has to start here. I know that it can't go like this because it's not allowed to touch that root there. There's no roots on that side. So I know it doesn't go down. Instead, actually, it would have to go only one way, and that's up. And there's that graph. So we're actually done. So this one was a little bit easier because there was enough information just to know what the lines should look like without having to plug any points in. But there is one more thing that we need to do still. I forgot about the hole, so let's go back now and do that. We should have a hole at x equals -3. Well, x equals -3 is about here, and so that's going to be right there. So you're just going to draw an open dot right there, and that's where I'm going to have a hole in my graph. Okay? And that's it. Let's go ahead and take a look at one more of these types of problems. I know these ones are a little brutal, so hang in there with me. We've got one more of these types of problems. All right. So, determine the end behavior by looking at n and m. So in this case, my n is 2 and my m is 1. And therefore, n is greater than m. Now, when that happens, we have to. There is no horizontal asymptote, so we're going to have to figure some stuff out here, and this part requires a little bit of work. What we're going to do is we're going to take our function here, and we're going to plug in infinity and negative infinity, and we did this a little while ago. So what you do is you take the first terms, x squared over 4x, and we're going to find the limit of this as x approaches infinity. And what that means, this is the right side of our graph. We want to know what's happening on the right side of our graph. Well, the first thing I'm going to do is I'm going to reduce it. I'm going to write the word right again. We're going to reduce this. So if I reduce that, I end up with x over 4. And if I'm finding the limit of infinity, I'm just going to plug this in here for x, and I get infinity over 4. Now, if you divide infinity by 4, you just get infinity, and that means up. So on the right side of my graph, I am going up. So the right side of my graph will look like we're going in an upward direction. Okay? Let me erase this and make some space. The right side of my graph will go upward. Okay? Let's do the left side of our graph now. To do the left side, you're going to repeat this process, but you're going to do negative infinity for the left side. Once again, we're going to want to reduce. And then you plug in your negative infinity. And negative infinity divided by negative 4 is just negative infinity. So that means down. And so on the left side of my graph, we're going in a downward direction. On the left side of my graph, we're going downward. Okay? So that's what my end behavior looks like. There's no asymptotes. There's no horizontal asymptote. In other words, it doesn't get flat on the left and right. Instead, the left and right are arrows pointing up and down like that. And so we're done there with that one. That's option 3. All right. Let's go ahead and take a look at part B. For part B, once again, we're going to do the rest of the problem is very much just the same thing. Okay? So for part B, we're going to plug in 0 for x. Which just gives me 0 over 12, which is 0, so my y-intercept is 0. Okay? So we've got 2 useful pieces of information. I know what the left and right side of my graph looks like, and I know that the y-intercept is 0. Let's continue looking for more stuff here. Step C is to factor the numerator and denominator. So if I factor that numerator up there, I'm going to just use GCF on that. I get that. If I factor the bottom, that's also just a GCF. I get this. Step D, factors that cancel give us wholes. Well, there's no factors that cancel here, so that does not apply. Let's take a look at part E. Factors left over on the bottom give vertical asymptotes, so that would be this guy here. So I have a vertical asymptote at -3. Let's go ahead and take a look at the last one here, part F. Factors left over on the top give us roots, so I have 2 of those. We have x equals 0, and we have x plus 2 equals 0. So this one's done already, but this one we need to subtract 2 on both sides. And so these are my roots, or in other words, that's the places where it touches the x-axis. So now we've got all the information we can gather, and we're going to go ahead and give graphing a try here. So draw a graph. So first of all, on the left side, it's going down. On the right side, it's going up. So I'm going to go ahead and draw that now. Down on the left, up on the right. My y-intercept is 0, so it touches the y-axis at 0. I have a vertical asymptote at -3. And I've got roots at 0 and -2. And there's that. And now we're ready to go ahead and connect our dots. Now, I have to use this arrow as my starting point here, so I can't go up like that. And the reason why I'm not allowed to do that is because if I do that, I'll be touching the x-axis, and there's no roots there. We've already found all of our roots, and there isn't one located there, so I'm not allowed to do that. So the only other option I can do is have it curve back down to get flat against the asymptote on that side. On the right side, I'm going to start over here at this arrow. I've got to come down, hit that root, and then swing back up like that. And there we have it. Okay? So that's the end of that. So for number 24, this is what I'm going to call a special rational function. This is also rational, but it's just of a special kind that has this form to it, which is what this one is. Matter of fact, I might want to start by putting in some missing numbers. I'm noticing that there's no N or H there, so I'm going to rewrite it so it looks a little bit more familiar. If there's no H, you can assume that it's 0, and if there's no N, you can assume that it's 1. So There's that. So let's go ahead and begin here. The vertical asymptote will be at h. H equals 0 in this case. Next, we have the horizontal asymptote will be at k, and k equals 2 in this case. So let's go ahead and sketch those things. I have a horizontal asymptote at h equals 0. Oh, you know what? My bad. It goes this way. Vertical asymptote, sorry. Vertical asymptote. And then we have a horizontal asymptote at k equals 2. Okay, and I'm just using a highlighter this time to represent my asymptotes. Next, we need to determine the shape. So we look at two things. We look at a and n. We look at the a value on the top and the n value here. So in this case, my a is -4 and my n is 1. My a is negative and my n is odd. And therefore my shape will look like this. And it gets flat up against those asymptotes that we graphed, the yellow and green asymptotes. So there's those ones. So these ones are much easier than the general rational functions. They're more like the rest of the things we're graphing in this unit. But they are a special kind of rational function. All right, let's move on to number 26. We're going to talk about graphing exponential functions now. All right. So the first thing that we're going to do is we're going to find our horizontal asymptote, and that will be at c. So in this case, that is 1. So for part A, my horizontal asymptote is at y equals 1. Next, we're going to find our y-intercept. The y-intercept is at a plus c. So that's -5 plus 1. So there's my y-intercept. So at that point, we're ready to start graphing stuff. I have a horizontal asymptote at 1. So I'm going to draw a horizontal line here at 1. And then I have a y-intercept at -4. So I'm going to go down to -4 and put a dot there. The last thing that I need to do is I need to figure out the shape of my graph, and it's based on the values of a and b. So we're going to look at a and b. Is a positive or negative, and is b greater than 1, or is it between 0 and 1? Well, let's take a look. My a value is negative, and my b value is between 0 and 1, and therefore I'll be using this kind of a shape. So it's going to be flat against the asymptote here, and come down, swing, and hit that point, and that's that. Okay? So that's how we graph exponential functions. Let's go ahead and move on to number 28. Talk about graphing logarithmic functions. All right, so for logarithmic functions, the first thing that you want to do is you want to find your domain. And you do that by taking the part that's in the parentheses there and making it greater than 0 and solving. When we're all done, that will also tell us what our vertical asymptote is. So for part A, we're going to take 4x plus 3, and we're going to make that greater than 0, and we're going to solve that. For these kinds of problems, I would recommend going with decimals. I just think it's a little bit easier. Now something you want to keep in mind for these, you guys, is that if you ever divide by a negative, you're going to have to flip your inequality around. But in this case, I didn't divide by a negative, so I'm not going to do that. But do be aware that is a possibility. Okay? So what this means is that I have a vertical asymptote at x equals negative 0.75. The next thing I'm going to do is I'm going to pick two x values from my domain and plug them in to find out what y is. So we're looking for numbers that are greater than negative 0.75. So I think a good choice would be 0. And let's pick another number that's bigger than that. And when you're doing log functions, it's a good idea to pick a number that's a lot bigger, more than just one space. You want to give them a little bit of space. So I would say at least 5 spaces greater, sometimes even more, like 10. Otherwise, it's kind of, you'll find that the y values are so similar that it almost looks like a flat line, but it's really not. So the more space you give between your x values, the better. Okay? So we're going to go ahead and solve for y now. So how do we find these y values? Here's how we do it. We're going to plug it into our function and simplify. So we have log y is equal to log 1/4 of 4x plus 3 minus 5. Now in this case, I want to plug in 0, which gives me the following. 4 times 0 is 0, plus 3 is 3. Now for this piece, we want to do the change of base formula. And the way that that works is you're going to do log base 10 on the top and bottom. This number goes on the top. The other base goes on the bottom. And from there, this is all a calculator thing. So I'm going to punch this into my calculator and I'll see what I get. Log 3 divided by log 1/4 is negative 0.79. And if I subtract those, I'll get my final answer, which is negative 5.8, we'll say. Okay? We're going to repeat that process now, but for our next y value. So instead of plugging in 0, I'm going to plug in my next x value, which is 5. Okay, so here we go. That's 23. Then we do change of base. And let's see what my calculator gives me for that. Negative 2.261 minus 5 gives me negative 7.3 if I round to the nearest tenths. So there's that. So now we're ready to plot and connect. All right, my vertical asymptote is negative 0.75. So I'm going to go, if this is negative 1, then negative 0.75 would be like probably like right about here. That's my vertical asymptote. The next thing I'm going to do is going to plot these points. 0 and negative 5.8. So let's find that point. Negative 5.8 would be pretty close to negative 6. And then this one, 5 and negative 7.3. So I'm going to go over 5 and down to about negative 7.3, which would be like right about there. And it's got to be one of these shapes. So which of these shapes could I connect these dots with and end up with it getting flat against the asymptote? Well, it'd have to go like this. So it looks mostly like that one there. But there's our final answer for that. All right. We'll go ahead and do one more. This is another log question, but actually a little bit easier. 29 is an ln, and 30 is a log, but you'll notice that there's no base here, and that means it's base 10. Now, both 29 and 30 are a little bit easier because the only reason why they're easier is because you don't have to do the change of base in order to evaluate the expression. You can kind of just skip that step. All right, so let's begin here. Part A is not going to be any different. We're going to take the part that's inside of the parentheses there, and we're going to make it greater than 0 so that we can find our domain. In other words, the possible values of x. Once again, if you're doing this and you end up dividing by a negative, don't forget to flip your arrow around, but in this case that doesn't apply. So I know that x has to be greater than 3. And this also tells me that my vertical asymptote has to be x equals 3. So for part B, I need to pick values of x that are greater than 3. So how about 4? And then the next number I pick should be a pretty good distance away from 4, so let's go ahead and say 14. Okay? Now I need to find my y values. And to do that, we're going to plug these numbers in to my equation up here. So here we go. And this is where the fact that this is base 10 comes in kind of handy. It's because it saves us a little, just a little bit. Not a lot, but it saves us a little bit of work. 8 minus 6 is 2. Now this is a base 10 log of 2. When you have a base 10 log, you don't have to do change of base. You can just type that in your calculator just the way it appears. So log of 2 is 0.3. And adding those together, we get 1.3. The same kind of thing applies on number 29. If you choose to go back and practice number 29, which is an ln function, you don't have to do change of base on that either, because we have an ln button on our calculator as well. The only reason we have to do change of base is because most calculators do not have a button for other types of logs. They've only got buttons for base 10 and base e. So now we're plugging in 14. (28 minus 6 is 22. Log of 22, once again, directly in the calculator, no change of base needed, is 1.3. And adding that to 1 gives me 2.3. And we're good to go. Now we're just about ready to graph this thing. So, without any further ado, here we go. Plot and connect. So my vertical asymptote is x equals 3. So I'm going to go over 3, and I'm going to draw a vertical asymptote there. Next, we have 4, comma 1.3. So I'm going to go over 4 and up 1.3. Which would be approximately here. And then my next point is 14 and 2.3. Way out there, and 2.3 would be about here. So we're connecting these dots like this, and we need to get flat against the asymptote, so it'll be like that. So in other words, it's resembling this guy the most here, it would seem. Okay? And that's the end of it. So I know that was a long one, Hopefully that was helpful, but we'll see you guys in class for a review test on graphing tomorrow. Till then, have a good one.